Okay, Mr. Gazda here. Welcome. Applied Physics, homework 27. You need a reference table, you need a calculator. Let's not forget, the goal of this is you learn how to do it. The goal of it is you learn how to do it. That's why we're doing it. Just copying or just following along and not learning it is bad. Okay, here we go. Baseball pitcher throws a fastball at 42 meters per second. If the batter's 18 meters from the pitcher, approximately how much time does it take for the ball to reach the batter? So let's, I like to do this. Let's fill out the variables. We have fastball, so velocity is 42 meters. The batter is, that's the distance, is 18, I'm sorry, this is meters per second, 18 meters, and we're looking for time is what we're looking for. So go to the reference table. I've numbered the first few 1 to 5. We have V, T, and D is going to be the first one. Let's do it. So V equals D over T, with the distance being 42 meters over second and the time being 18 meters. Okay, we can do that math. Oh, you know what? I got that wrong. See, I made a mistake. I'm trying to go quickly here, and it hurts me. So be careful, showing that these mistakes happen. It's the other way around. 18 meters on top is the distance, and the time is here, and the velocity is 42 meters per second. Okay, so what you want to do is I'm going to rewrite this. 42 meters over second equals 18 meters divided by time. You will probably realize you put that over 1, cross multiply, and then as you simplify, you're going to end up getting T equals 18 meters divided by 42 meters over second. So you can do that math. Let's do the units first, and the keep change flip method is going to be like this. Meters, change the symbol, flip them here, go like this, put that over 1. Meters cancel out. What I'm left with is seconds, which makes sense, time being in seconds. Therefore, and you do the math on your calculator, 18 divided by 42 is going to be 0.43 seconds is your answer for the first one, number 4. Okay. Let's do the second one, which is number 5. The velocity of an object in linear motion changes from 25 meters per second to 15 meters per second in 2 seconds. So that is going to be our delta V. Delta V is 10 meters over second, time 2.0 seconds. What is the acceleration during? Acceleration equals this. To our reference table, acceleration formula we're going to use. We have to look around a bit. We the second one, change in velocity over time. Acceleration equals change in velocity, 10 meters over second divided by time, 2.0 seconds. 2.0 seconds. Let's do the units. Keep change flip method. Keep change flip method is meters over second, and then I change the symbol. I put this. That's seconds over 1, so it's going to be 1 over seconds. So meters times 1 is meters. Seconds times seconds is seconds squared. It's going to give me the answer. We know acceleration is often in meters per second squared, so that feels good. And then it's 10 divided by 2. Acceleration equals 5 meters per second squared for A. That's A, acceleration. Okay. Let's go on to the next one. Okay. 6. Object initially traveling in a straight line with a velocity of 5 meters per second north is accelerating. Let's see if the north means anything here. Is accelerating uniformly at that rate, 2.0 north for 4.0 seconds. Oh, it's all north. So the north is, don't let it throw you off. This is all just going in the straight line. They're trying to show the north that it's all in the straight line. So this is going to be initial velocity. Okay, initially. So it's VI is 5.0 meters per second. and then acceleration is 2.0 meters per second squared. Time is 4.0 seconds. And now we're trying to find distance. What is distance? So, we got to look. VI, A, T, and D. VI... No, we need to find distance. This is not going to work. There's no distance. This has distance, but doesn't have final velocity. It's going to have to be number 4. Okay, let me copy that down. D equals VI T plus 1/2 A T squared. Okay, so, and D is what we're trying to find. Distance equals, so it's 5 meters over second times 4 seconds plus 1/2 2 meters per second squared times 4 seconds squared. Alright, so that seems like a lot, but just attack it a little bit at a time. Let's do this. I could probably put that over 1 and realize, and you may have to work this out, that this is going to be 20, and the units are going to be, the S and the S will cancel out. That's going to give me 20 meters plus. This here is going to be, well, let's maybe simplify. 1/2 2 meters per second squared. This is going to be 16 seconds squared. Hopefully you can see that. And what we're going to get is, if we do the numbers, I'll do the numbers first. I'll do 0.5 as a half times 2 times 16. That right? That should be right. 0.2 a half times 2 times 16 equals 16. Okay, so the number here will be 16 is 20 meters. And let's see the units here. So let's do the units separately. I'm going to go back to a different color pen here. And the units will look like this. Meters per second squared. And it's just times second squared. Put that over 1. These cancel out. These cancel out. What am I left with? Meters. That's my unit. Which, if I go back here, okay, it's nice. I can add they have to have the same units to be able to add them, and they do. 20 plus 16 will give you your distance, in this case, of 36 meters. 36 meters for, what's that, question number 6. Okay, so hopefully you're following along here. Let's do 7. 7. An object initially at rest, that's good. VI equals 0 meters per second. Accelerates uniformly. Okay, gives me the acceleration. Just 5 meters per second squared. Attains a speed of 30 meters per second. That's going to be VF, 30 meters per second. What's the total distance? Distance equals, that's my question mark. So, I have VI, so this here, I'm trying to find D. This has D, but it doesn't have time, and we don't have time, so I can't use 4. By looking around, you should settle on this is the one here, because I have VF, I have VI, I have acceleration, I don't have D. Let's do this. Okay, so that formula is, it's VF squared equals VI squared plus 2AD. VF squared is 30 meters over second, that's squared, equals initial velocity is 0, which is kind of nice, it kind of drops out, plus 2 times 5 meters per second squared times D. Okay, 30 meters per second squared. So 30 squared, and I don't have a button to square it on here, so I just do 30 times 30 is 9. That number is 900. 900, and then meters per second squared is going to give you this. Let me just do a little on a side here. I'll just do meters per second times meters per second. Okay, proper Glurfing format. Meters times meters is meters squared. Seconds times seconds is seconds squared. And that may seem weird to you, but that's going to give you your units right there. And this is why we did all that Glurfing stuff at the beginning of the year. Okay, I'm off the thing. Here we go. So that's that, and then the 0 drops out. 2 times 5 meters, that's going to be 10 meters per second squared times d. And now I want to get d by itself, so I have to divide that. What I do to one side, I need to do to the other. And so this is 10 meters per second squared. Okay, this is where it's getting a little weird, this section right here. And the units are really key. Do 900 divided by 10. That's pretty straightforward. That's 90. The answer is going to be 90. Let's do the units, because it's division. Let's do keep, change, flip. So I'll do them. Meter squared over second squared, and then I'm going to change the symbol to multiplication. Do second squared over meters. Now let's cancel. Second squared over second squared, cancel. This meter cancels with this. What I'm left with is this is my remaining unit. And then I go to 90 meters equal distance. That's a d, and that makes sense to me because distance measured in meters. There we go. Okay, let's do the next one. Here we go. A stone is dropped from a bridge 45 meters above the surface of a river. What is the time required for the stone to reach the water surface? So, what do we have? Stone. What do I have? I have distance. Distance equals 45 meters. Time I'm looking for. Oh man, I don't know much else about it. But I know we touched on it briefly. The one thing you do know is that it is falling. The acceleration rate is constant. It is the acceleration due to gravity. It's on the front page of the reference table. 9.81 meters per second squared. 9.81 meters per second squared. So that is key to realize that you know the acceleration of anything falling. 9.81 meters per second squared. Okay. The other thing, I think, so let me see. So you have that. Now, D, I don't really, this has, but these 1 or 2 won't work. It would be nice if they did, but they don't. I need something else. I need one of these other ones. What else do I have? I don't know final velocity. I don't know how fast it's going. I'm trying to figure out, what am I trying to figure out the time? But I do know something else. I do know initial velocity. In its downward motion, vertical motion is going to be 0, because I guess they assume you're just kind of holding the rock. It wasn't already falling. So that's key. So, with that said, now I can use this formula here, the fourth one. D equals via that one. So let's do that. Let's do D equals VIT plus 1/2 AT squared. Okay, D I know it is 45 meters. Initial velocity, that's 0 times time. This is 1/2 acceleration, 9.81 meters per second squared times t squared. Now, this is going to drop out. T times 0 is just 0, so that's nice. 1/2 of that, 45 meters, equals, it's 4.905 meters per second squared times t squared. Okay, is that. Now, I have to get t squared by itself, so I divide this by this. That cancels out. What I do to one side, I must do to the other. 4.905 meters per second squared. So, that leaves me with, 45 divided by 4.905 equals 9.17 is the number. Now let's do the units here. The thing is, the units are this. So this is my sort of problem. This is my division problem right here. Meters second squared. Let's do them separately. Meters, and now keep change flip. So I'll do second squared over meters. Do that. What happens here? Cancel out. Cancel out. I have second squared, which you may find to be. Let me rewrite this. So that's here. Second squared equals t squared. So how do I get just t? I have to square, right? Do the square root of each side. The square root of t squared will just give me t, which is the answer I'm looking for. 9.71, do the square root of that. Ooh, sorry, I messed that up. 9.17 square root of that is 3. I'll just round this to 3.03. The square root of second squared is just seconds. That gives me the time. There we go. Okay. This video is getting a little bit long, and I think I did a lot. Hopefully you're on a bit of a roll. And for the last one, number 10. For number 10, I'll just tell you the formula you need for number 10 is you're trying to find the final velocity. So this is the formula you need for it, and I'll let you just plug that in and work that out. So this is a good hint. Plus 2AD. Use that formula, plug it in, you'll be able to get an answer. And I'm also going to say on the back, this requires some thinking, but it is very doable. Apply what we've learned so far. You may want to skip 72. I'll give you the opportunity. You could skip 72. I think people get hung up on it a bit. So do 71, do 73, do 74 on your own. These two are calculations. This is just describing in words, but describe it thoroughly in words. Do the work down here. Show your work. And good luck with that. I hope this helped. Your goal is learning this. And come see me if you have any problems beforehand, because this is something that we need to know. Mr. Gazda, signing off.